we're officially begun. Excellent timing there. And so I haven't changed. I haven't added any assignments, but I may post an assignment today later on. And so still have just this assignment on how to enter answer. And that's Monday. Now, remember, you can go ahead and enroll in the WebAssign following the instructions in the syllabus, and you don't have to purchase WebAssign yet. So we have a 2-week grace period, and I think it won't end until I open the class, I opened the class last Wednesday. So I think it's 2 weeks from that that you can still enroll and work in WebAssign without having to formally register. And that when you register is when you pay. So in other words, you don't have to purchase it yet. So there's no reason to go ahead and there's no reason to not enroll. So you want to go ahead and enroll, and you can work on this assignment and have that done by the 31st, right? Which is next Monday. I forgot to mention last time, this is not apropos of this assignment, but I forgot to mention last time that you'll need a calculator of some sort, right, throughout the course. Now, a lot of people use their phone, which is really convenient, me included, for your calculator, but you won't be able to use that on an exam. You cannot use your phone on an exam. So you'll need some other sort of calculator. It doesn't have to be anything fancy at all, just as long as it's a scientific calculator. So as long as it has, the trig keys on it, sine, cosine, and tangent, which that's fine. Okay, it doesn't have to be a graphing calculator, but have a graphing calculator from a previous course or from high school, you're welcome to use that. So you can use your graphing calculator. I have no problem with that. But otherwise, you need to get some simple scientific calculator, at least for taking tests. You might be able to borrow one just for taking tests and use your phone at other times, right? But that's going to be necessary, right? Okay. You can often buy scientific calculators at dollar stores really cheap. Okay, they used to be for sale, not just for function calculators, but scientific calculators at dollar stores. You can find them. That's perfectly good for our purposes. So there's nothing else new there posted in WebAssign. There's nothing new in Blackboard either, except that I put the stuff from last week, right? So the class notes from last time, which we're going to continue with today, and then there's the video link. There's the link for the lecture, right? The recorded Zoom lecture that I'm recording right now. So that's actually housed in YouTube, but the link to it is here in Blackboard. So probably once you link to this and find it in YouTube, you wouldn't really have to go through. And once you know that channel, then you can that YouTube channel, then you can go directly there. You really wouldn't have to go through Blackboard. But anyway, it's on Blackboard. The notes are on. The link is on Blackboard, and the notes here are on Blackboard as well, right? And this class syllabus is there, right? Don't forget. But I gave who were in class last time a paper copy of the class syllabus for those people that are online. You can find the class syllabus there in Blackboard, and that's where it has the instructions for how to enroll in WebAssign. So if you're looking for that, I didn't open the syllabus, but you guys can see me thumbing through these pages. I think right here on this page, that's page 4. There are the instructions for how to enroll in WebAssign, right? Okay, and then once you get enrolled, and with a user ID and a password, and you keep going back to that site, it's going to remind you about registering, and it's going to give you all the instructions about registering, because of course that's how they get their money. So they're not going to be lazy about reminding you about registering for the class. Okay. If you need a syllabus, for those people, for someone who's in class, if you didn't get a paper syllabus last time, is anybody who wants a paper syllabus who wasn't here last time? Emil, you were. So it's kind of long there, but just got the usual syllabus details. The only thing that's a little bit unusual is the extra credit system, which is at the back, right, which is called flux dollars. So if you didn't hear that description last time, then go to the back of the syllabus and read about how you can collect flux dollars and spend flux dollars at the end of the semester. That's how we give extra credit. That's how we do extra credit in this class. You can also read about the attendance policy. So we do have an attendance policy, which I'm going to start today. And in a few minutes, I'm going to pass a roll sheet out for the people who are in class. But for you guys that are online, Zoom is going to take a roll for me. So so I'll know about the people that are attending via Zoom, right? Okay. But for class, I'm going to pass out the roll sheet here in a minute. Now, another thing I'm going to pass out, so you won't get the benefit of this online, is a little bit of back paper. Did y'all bring back the back paper maybe last time? Okay, so if you have that, then you pull that out. We can. We're going to use that today. And then index cards. I need you to have a blank index card. You bring back one of your index cards from last time. I need one that's blank. Okay, so for you guys that are in the Zoom universe there, you'll need something you can graph on, but it doesn't have to be formal graph paper. So anything you can write on will do. May not just get as pretty a graph as some of the people in class. Okay, the index card will not apply to you yet until you actually are here in class for the first time. One index card. Okay. Have a blank. It's got to be blank. Have a blank one left over from what I passed out last time. Last one. Okay, excellent. Got that. All right. So made some other paper to write on too. Making some other paper to write on too, besides the graph paper, because we're getting ready to do something right now that doesn't really require graphing, but you're going to have to write on. Before we start that, though, y'all have any questions that come to mind immediately? Oh, I forgot. Yeah. So anybody need extra graphing paper? Sorry about that. So sorry, these people. I'm going to have to pass that graphing. I'll be passing out graphing paper frequently. You probably will end up not always using it, so I can get graphing paper that I get from the university. Okay. Anything else? Now, when we start graphing, we might do 2 or 3 things graphing paper eventually. So don't try to conserve your graphing paper is what I'm telling you here. Don't write everything like write big something. So you might try it. Try to get quadrants there to conserve it a little bit. But there is more, so you can always have more. Okay. So any questions from my Zoom audience there? So I will have questions for you guys. Don't forget. So I may just at any point, it really won't be quite that abrupt, but I may at some point call on people that are in Zoom or in class, right, to answer, questions. So I'm not cruel about it, but well, sometimes I can be about it, but usually I'm not cruel about it. But it's just a way of keeping everyone engaged. Okay, and that's so important in the math class. That makes such a big difference in the ultimate results that we get. Okay, I think now I've wasted enough time here, so I can pass out the roll. So the way the roll is going to work is, just going to sign in a slot. Use your signature, but make sure it's legible. So if you have some grades out of practice, for right. That's great, but I have to. So I'm going to get legible. but you're gonna sign the same way every time. So, and you'll sign the same spot, and so for you, it'll be spot. Right, okay, and then just choose the next available slot, sign there every number, you'll sign there every time. When you're not in class, I'll put your name here from the Zoom, okay? Okay, so passing that around. Don't let me forget that. So for you guys online, I'm going to fill your name in on the roll, right? From my Zoom attendance log. Okay, so you'll be taken care of. All right, so finally here, let's switch to the notes. I have a little recall practice for you guys to do. So let me move my Zoom boxes around here. Can y'all see that recall practice? It actually says number 4, but that's because we're in the middle of this of these notes from last time. This is the same notes. See those 2 points that are plotted there? Can y'all see those at home? That one of them is at 3, 4, and one of them is 8, -1. You don't have to plot those yet, although we are going to plot them later. So you can plot them now if you want to, but that's going to waste a little time, because what I want you to do is recall from last time, okay? I want you to find the midpoint between those 2 given points, right? Okay, so 3, 4, and 8 -1. Find the midpoint, and then find the distance between those 2 points, right? Okay, so last time we talked about the midpoint formula and the distance formula, correct, right? Okay, in class. So we just want to do a little recall of that, right, to remind you of that before we see that again today, okay? If you need some help with that, I'm going to round, right? So for you guys in class, you guys on Zoom, you know, you can just look in your notes, right, and find the midpoint formula, right, and the distance formula, because we did those last time, right? Okay, but for the people in class, I'm going to go around and just see how they're doing, all right? So we don't spend too much time. This is just for recall. So I would just put this on regular paper. Let's say the graph paper. Now, if you need to ask the person next to you, that's fine. This is not something that's great. It's just to get us reminded. No, I just want you to answer the question. Remember. So you are my. Oh, so doing a little recall now. That's the question. Find ourselves. Yeah. Oh, I see. So someone there is a mid. And I think so. Is this what that was how we derived it. That's it. So you add it. And then you average the. I think that's how you work this. Okay, guys at home, did you find that in your notes? Those two formulas. Okay, so everyone signed here. We have 12 people here. Sound right? Ruby, all right. And about 20 online. So that's 32. So that's all on the roll. At least that was this weekend. All right, so are y'all able to do this? Do I need to come by and help you again? There's no one. Yeah, all right. The recall practice is the recall practice. That's how we're finding. Oh, I see this recall practice was very helpful here. This recall practice is very helpful because I know how to code. I can see on. So here's use that. It's easy to remember. It's easy. Yeah. Yeah, so that's what about this? This one? Is it? Yeah, what is it? Okay. All right, let's so I know y'all are still working on parts of this, so that's fine. But let's start with the midpoint. Okay, finding that midpoint. So I'm going to lower the screen here because I will write here in just a second if I can get all my wiring out of the way. All right, so let me switch back, find the notes here. Okay, so for that midpoint, so there was a lot of confusion there. I saw that some of y'all didn't write down the when we were going through the midpoint, y'all didn't get a chance to write that down correctly. But the midpoint formula is easy to remember without remembering the formal formula for the midpoint, because it's going to be the the average of the can y'all see that at home again? Guys, did I lose?
Yes.
Okay.
Yes, sir.
Yeah, I'm sorry, I lost y'all for a second there. All right. It's going to be just the average of the x coordinates and the y coordinates of the points. Okay. So, and the way you average numbers, right, is you add them and divide by 2, right? If there's only 2 numbers, you just add them and divide by 2. So to find the midpoint for these 2 points, okay, to find the midpoint for these 2 points, all we have to do is add those 2 x coordinates, the 8 and the 3, and add the 2 y coordinates, the 4 and the -1, and divide by 2. Okay. Did y'all get that? What y'all get at home? Someone get that home? Can you type that in for me in the chat, or you can say it also? Someone online?
I got 11.5 for the X and 3.5 for the Y.
Yeah, I think you mean 11 halves, right?
Well,
Yeah.
I mean, yeah.
Right. Okay.
Yeah.
Not 11 1/2, but just 11 halves, right? And for
Right.
the y coordinate, yes, 3 halves, right? Okay. So
Right.
exactly.
But are we supposed to make it an improper fraction? I mean, not an improper fraction.
No, you can
but
leave it just like this. This is fine.
Okay.
So and the way we got that 11 halves, right, was just 3 plus 8, right, divided by 2, right? So that's 11 over 2, which is 11 halves, right? And of course, the way we got the y coordinate is just 4 plus the -1. So that's going to be 4 minus 1 divided by 2, which is 3, right? So there's the 3 halves. Okay, perfect. So now the way that formula looks, remember, if you write it down formally, so I saw people had it written down in their notes, but they didn't realize that was the midpoint formula. It's just the sum of the 2 x coordinates, right, divided by 2. In other words, the average of the x coordinates, and then you add the 2 y coordinates together, right, and you divide by 2. So there's the midpoint formula. Now the distance formula maybe is a little bit harder because maybe the arithmetic is worse, right? So by the way, where is this point? 11 halves and 3 halves. So 1, 2, 3, 4, 5.5 on the x-axis, and then 1.5 right there on the y-axis. So there's the midpoint. That looks about right, right? Okay. I think that point does look like it's halfway between those 2 points. Now, the distance formula will tell us, of course, the distance between the 2 points. That midpoint is half of that distance between these 2 points, but the distance formula will tell us the total distance between those 2 points if we can remember the distance formula right. Remember, it was derived from the Pythagorean theorem, but you don't have to use the Pythagorean theorem each time you want to compute the distance, because we have that distance formula. Okay, so what was that distance formula, and recall that. So remember, what do you do in computing distance? It involves a square root, so you should always keep that. You should always remember that it's going to have a square root in it, right? But what goes underneath that square root? Yeah, there's some parentheses there. What do you do in the parentheses?
8 minus 3 or 3 minus 8.
Yeah, you take the difference in the x coordinates, right? And you square that. And then you take the difference in the y coordinates and you square that also, right? Okay. The reason what that difference in the x coordinate gives you is that's the horizontal distance between the 2 points, right? And this is going to be the vertical distance between the 2 points. And then those turn out being sides of a right triangle, right? Okay. And then you square those and take the square root, and that will give you the length of the hypotenuse of that same right triangle. And that's the distance. Okay. So you don't really need to recall that, all right? How the distance formula came about, but you do want to remember the distance formula. There it is. Okay. What did you guys end up with here for the distance? Square root of, what did that turn out to be? What? 50. Okay. Did we have some agreement there? Someone disagree with that? Square root of 50. You got slightly different. So you came up with what?
I did 8.3.
So you did 8 minus 3, which is 25, 5 squared, right? And then what? Oh, -1 minus 8. Yeah, it should have been 4, right? Okay, so you came up with just too big of a number. So square root of 50 is the distance. That's about approximately something a little bit bigger than 7. Is it what, 7.07? Yeah, so very slightly bigger than 7, because 7 squared is 49. So 7.07 squared apparently is close to 50. You do not really have to simplify this, but you can slightly simplify by hand square root of 50. You cannot completely simplify it by hand because 50 is not a perfect square. Square root of 49, of course, you can completely simplify as 7, but 50 is not a perfect square. When I say simplified in this class, that means carry out all the arithmetic you can by hand. Carry out all the arithmetic you can by hand. And well, by hand, we cannot really completely simplify square root of 50, right? But let me show you what you can do. You can write the 50 as 25 times 2. Now, that's not always helpful to do, but in this case, it is helpful. Of course, you can also write it in other ways as well. 5 times 10, for instance, is also 50. But the reason I wrote the 50 is 25 times 2 is 25 is a perfect square, and you can extract the square root of the 25. And of course, that's 5, but you can't do anything with square root of 2. 2 is not a perfect square, right? So that has to stay under the radical. So you end up with 5 times the square root of 2. That's the simplified by hand version without a calculator of square root of 50. Okay. So sometimes I will simplify things completely by hand like this. Sometimes we'll just be happy with writing down our decimal approximations. Okay. All right. So well, okay. So that was good recall practice, because I can see that that these ideas were a little bit fuzzy, but these formulas are really important. We're going to use them again and again. Okay, now let me get to something that you don't doesn't require much recall practice. This is stuff that you already know. Here's how we're going to use the other index card for me, because I need to learn people's names and I only know a couple of them so far. So I need for you to make name tents for me so I can see those, and that's how it will help me learn your name. So when you come to class, guys, this is one thing you're going to get to do is make a name tent for me that you can use in class. When now, what you want to do, let me show you how to make a name tent, is take one of the index cards, obviously, right? Okay. And you're going to fold it what's called hamburger style. So from the long ends, don't, this is hot dog style. That makes more sense, right? Because that looks like a hot dog, but gonna fold it hamburger style like this, right? Okay. And that of course just makes a little tent, right? And then this is what you're gonna put on one side of the tent, though. I want you to put your name right in the middle there. Make sure you use the name that you go by, right? Okay, so the name you want me to call you. You don't have to put your last name necessarily, but you can. So first name there, at least, right? And then just some information about you, so so I'll know something about you. So in the top left-hand corner, put your major, okay? And then in the top right-hand corner, put your favorite book or movie or song. If you can't think of your favorite right now, just, you know, whatever, maybe the last song you heard, right? Okay, you can put that on there. Or the last movie you saw, you can put that on there as well. All right. So, but if you have a strong favorite, put that down there for me. Okay. And this is how I learn new things, by the way, because I often don't know books, movies, or songs. And then here below that, put your favorite food. Okay. So you can guess. There's always there's always strong favorites in class, right? But put your favorite food. And then in that bottom left-hand corner, this is the part that's hard. I want you to draw a picture. It's got to be a picture of your favorite pastime. All right. So see if you can draw a picture of what you do to pass the time, right? Okay, what your favorite hobby is, but you have to draw a picture, okay, of that. Don't make it an obscene picture, right? So I don't know what your favorite pastime is, but pick something clean here, of course, all right? Okay. And then draw a little picture of that. I'll give you a few minutes. Y'all can be thinking about this at home too, because I might ask you some of these things if I call on you at home, right? I may ask you what's your major, or what's your favorite book, movie, or song, or what's your favorite pastime, right? Or what's your favorite food is. But while I'm getting to know those names. And then after I've got to know people, I'll stop harassing you about what your favorite. What you do for fun, hobby. You listen to music, you know, read, dance. A lot of people play soccer. I only know that because people draw that a lot. Oh, I should make out mine, but I'll do that some other time. And then just when you're done with that, just put that on the just put that on your desk like this, right? So I can see it. Yeah. Oh no, you don't have to draw your favorite food. It was just draw your favorite pastime, right? You don't have to be a trained artist here for your pastime. Stick figures will do nicely. Okay, so again, when you're done, just put that right in front of yourself so that I can see who everyone is. How much you did it wrong. So you failed your first test there. All right, so, all right. You may have to turn it like this, so I'll have to read it upside down. Okay. All right. All right, so Robbie, is it Robbie? Robbie, so tell us about yourself. Stand up too. So this is Robbie, right, everyone? And just tell us what you, yeah, just stand up and tell us what you put there. So what is your major, Robbie?
My major is comp sci.
Computer science, okay. So, all right, great. And
Favorite book right now, I'm writing a research. So
the culture series, tell us what is that?
science fiction, series of books by Kim Banks. It's about a future human civilization at like, I don't know, it's about like the conflicts in there. Big space opera.
Oh,
And
okay. That sounds good, actually, right?
Favorite pastime? Well, pre-COVID it was traveling, and then during COVID running.
Running. Oh, okay.
And then favorite, right? I just did ramen and taco.
Okay, ramen. Yeah, I think about ramen. A lot of people eat a lot of ramen.
All right.
Okay. Yeah, no, that's great. All right. So tell us about yourself. I'm just going.
First, I did my name's
Okay.
I'm a biology major, and I wrote the part of my I really have a song or
What is your name?
pardon.
It's Harvey. Okay. Yeah.
And for my favorite food, I wrote anything I can cook. I love to cook, so I. Oh,
Okay.
every Friday, every Monday. And my favorite pastime, I love it.
Okay. All right. Yeah. So hang out. Everyone's there. That's fine. All right. Let's see. Oops, I don't see your. So your name is, how do you say that? Azelle, okay, all right, Azelle. So Azelle, you stand up.
My major is Harry Potter.
Okay, Harry Potter. Wings.
My favorite pastime.
Oh, okay, all right, so. Excellent. All right, so as we go through the semester, I'm going to get a chance to answer questions. I'll also down your interests and especially your name, right? Okay. All right. So, by the way, when you're at the end of class here, you can just leave your name on the desk. I'll collect those. So I'll keep track of those. So you don't have to keep track of that. And then I'll pass them back out next time. Okay. All right. So we're going to go back now and back into the notes. So where we left off last time and continue. And last time we had mentioned, remember, as we were talking about, there's the midpoint formula in the notes, right? Okay. So last time we had mentioned that when you have two triangles that are identical to each other, those are called congruent triangles, but you can also call them equal triangles if you want to. So identical means they have to have the same angles, right? Because these are triangles, so they're going to have three angles, but they also have to have the same side lengths, right? So same angles and same lengths of sides, okay? And obviously, if you have two triangles that have the same angles and same side lengths, then they're identical, right? Okay, they're equal to each other. And so the formal term for equal triangles like that is congruent, okay? Now, however, we've more frequently in this class, we're going to work with similar triangles, what are known as similar triangles. So similar triangles are indeed similar to one another, okay, but they're not completely congruent, okay? So two triangles are said to be similar to each other if they have the same angle measures, all right? So they've got the same angle measures, but they don't have to have the same side lengths, all right? And we're going to run into similar triangles in the class frequently, okay? And so they're going to be very useful to us, all right? We will sometimes run into congruent triangles, perhaps, but more frequently, we'll see, we'll come into contact with triangles that are similar to each other. They have the same angle measures, but they don't have to be the same size, okay? They don't have to have the same lengths on the sides, right? There's a very famous fact about similar triangles that called the similar triangle theorem. It actually has two versions to it, okay? It's really the same theorem, but the theorem is sometimes stated in two different ways, and both ways are useful, okay? But before we look at the statement of the similar triangle theorem, okay, we're not going to prove it, but we're going to use it a lot. Before we look at the statement of the similar triangle theorem, I want you on your graph paper, if you will, draw two similar triangles for me, okay? Two similar triangles for me, but which are not, okay? So draw two triangles that are similar, but not congruent, okay? So similar means they'll have the same angle measures, right? But the lengths of the sides will not be the same, okay? But can you think of what two similar triangles might? So obviously, if you draw two identical triangles, they would also be similar because they will have a similar angle, and they'll have equal angle measures, but I don't want the triangles to just have equal angle measures, but not be completely identical to one another. Okay, same at home there for me, okay? Oh, you're trying to. Okay. Those look like they could be identical. So yeah, but how do you? This is. Okay. Yeah, right. I see. So just cut these sides by half. Oh, okay. That's a good idea. All right, so y'all did pretty good there. Let's draw one here, and let's draw a pair of similar triangles here and see if y'all agree there. So these were supposed to be these were supposed to be similar triangles. All right, okay. So they look kind of similar to me, but I sort of stated that they were similar because in the picture, because I just put that this has this angle has measure C, this angle has measure C, this angle has measure B, this angle has measure B, this angle has measure A, this angle also has measure A, right? So since I just explicitly drew it, then I'm sort of saying there that those are similar triangles, right? Because they have equal angle measures. What you notice about similar triangles, right, is that it looks like one has just the enlargement or right, or shrinking the other one, right? Like on a Xerox machine, okay? It's like you've blown one up or you've reduced it, right? Okay, to get the other triangle. That's how similar triangles work. For you guys that were drawing similar triangles, you often used a right triangle, which is an easy way to create a similar triangle, right? Okay, so the way Robbie did it here, sort of, although he used slightly different numbers, was he drew one right triangle here, and he made the lengths of the two sides both the same. Okay, did I do that here? I meant to have 4 and 4. Yeah, all right. So he drew a right triangle, and then he just drew another right triangle, but he reduced the lengths of the sides, right, by the same ratio. So he, for instance, cut this side in half and also cut this side in half. So he put this vertical side down to 2 and this horizontal side down to 2 also, and then drew this second right triangle here. So these two right triangles also would be similar to one another. Okay. Another way to draw a right triangle is to, another way to easily draw similar triangles is to create an equilateral triangle. So an equilateral triangle has all 3 sides. An equilateral triangle has all 3 sides the same. Okay. So if you draw a triangle with 3 identical sides, that's an equilateral triangle. If the sides are all identical, if the sides are all the same length, by the way, then the angles are all the same. Also, they're all 60 degrees. And then you can just draw a larger equilateral triangle. So draw a bigger equilateral triangle, a bigger triangle where all the lengths are the same. And then all the angles will also be 60 again in the bigger equilateral triangle. So these two triangles also would be similar to each other. Okay. The angle measures would be 60, all 60s here. Okay. By the way, what are the angle measures here in these two similar triangles? If this one is 90, this one is 90, right? Degrees. What do these two have? What do these two have to be? 45, right? Because these two sides are the same length. This one is 4, this one is 4, this one is 2, this one is 2. So these 45. Two angles would have to be the same, and they would have to be 45 degrees each, okay? Because the angles in a triangle have to add up to 180, okay? So you add up these 3 numbers, you get 180. Of course, you add up these 3 numbers are all 60. You add them together, you also get 180, okay? All right, well, here are 2 more sort of random similar triangles, okay? Those aren't right triangles and those aren't equilateral triangles either. because the angle measures are not all 60 in these two triangles, but these triangles are supposed to be similar to each other. And here's the famous fact about similar triangles. Okay, this is the fact that we're going to use. All right, so in similar triangles, okay, in similar triangles, the fractions formed by the lengths of corresponding sides are all the same. Okay, all right, now that's a mouthful to say that in words. What did I just say? Okay, if you take the fraction, the ratio formed by taking one side of one of the triangles and dividing it by the corresponding side in the second triangle, okay, all right, that forms a ratio, right? Okay, so if you took this length and divided it by this length, I called this length A prime, just to distinguish it from this length, okay, which I called A, all right? If you take that ratio, those ratios are always the same for corresponding sides. So if you take B and divide it by B prime, you'll get the same thing, or as you get if you take C and divide it by C prime. Of course, you can also do the fraction in the opposite direction too. Okay, you can take A prime divided by A. That's the same as B prime divided by B. That's the same as C prime divided by C. Okay. By the way, let's look at that, Robbie. Let's look at that up here in these two similar triangles. All right. So the similar triangle theorem would say if I take this side. Okay, that's this vertical side here, right? That has length what? 4, right? And then the corresponding side over here is this side, right? That had length 2, all right? So if you take the 4 divided by 2, that gives you a number, right? That's supposed to be the same number you would get if you take this length and divide it by this length. Well, what's this length? It's also 4, right? And what's this length? Also 2. So of course you get 4 divided by 2 again, right? But that's also supposed to be the same as if you take this side and divide it by this side. Ooh, let's see if we know what's the length of this side. I mean the hypotenuse. What's the length of the hypotenuse here? Square root of 32. That's right. Yeah. That's square root of 32, because you would take 4 squared plus 4 squared gives you this length squared, right? So take the square root of 4 squared plus 4 squared, that gives you this length. So that would be square root of 32. What's this one? Square root of 8, right? So now we're wondering, does the square root of 32 divided by square root of 8, that better come out to be 2, right? Or our similar triangle theorem is not correct. Wow, is that right? Well, let's simplify square root of 32. Let's use that trick that I just showed you a moment ago. 32 is not a perfect square, but can you write 32 as a perfect square times something? How can you break down 32 as a product? 16 times 2, right? And that's useful, because 16 is a perfect square. What about 8? 8 isn't a perfect square, but can you write that as a perfect square times something? You can write it as 4 times 2, right? And 4 is a perfect square. So you extract these perfect squares, right? What's the square root of 16? 4. The 2 has to stay under here. What's the square root of 4? 2. But the 2 has to stay under the square root. But guess what? Those will cancel, and you end up with 4 over 2, right? So notice, oh, all of those ratios of corresponding sides, oh, indeed, they were all the same, okay? Well, that's always going to happen in similar triangles, okay? That's always going to happen in similar triangles, because that's what the similar triangle theorem says, all right? Now, there's another way to state the similar triangle theorem. It looks slightly different, but it's really the same, okay? So this is also called the similar triangle theorem, all right, okay? All right, so here again, I have 2 similar triangles, right? Okay, these are the same two as above. Okay, supposedly, all right? So I've labeled the three sides here. And so remember, we learned from that previous version of the similar triangle theorem, if you take A divided by A prime, that's the same as you take B divided by B prime, or if you, and if you take C divided by C prime, right? Okay, those ratios, those fractions all have to be the same. All right, the second version of the similar triangle theorem says this: if you take A and divide it by B, notice not A divided by A prime, but if you take this side and divide it by this side, that's going to be the same fraction you will get as if you do the same division in the other triangle. So if you take A prime and divide it by B prime, you'll get the same fraction. Okay, the numbers are not the same. A is not the same as A prime, B is not the same as B prime, but when you form these fractions, you get the same fraction. Okay, so A over B is the same as A prime over B prime. And you can do that with any two sides that you like. So if you take A divided by C in this larger triangle, that's the same as A prime divided by C prime in the smaller triangle. Or if you take B and divide that by C, this side divided by this side, that would be the same as B prime divided by C prime in the smaller triangle. Okay. So in similar triangles, the ratios of sides are often the same. Okay. The angles are not the same. I'm sorry, the angles are the same. The sides don't have to have the same length, but the ratios of the sides are going to be equal. Okay. All right, so I'm going to recapitulate here a little bit, just remind you these two different versions. So if you start with similar triangles, right, they have the same angle measure, but they don't have to be identical triangles, right? So if you take A and this side here, divide it by the corresponding side here, that would be the same as B divided by B prime or C divided by C prime. Okay, those fractions always turn out equal. Okay, so A over A prime is the same as B over B prime, or A over, I'm sorry, A C over C prime is the same as B over B prime. Okay. Likewise, if you have similar triangles, okay, if you take the ratio of sides in the same triangle, for instance, A divided by C, that would be the same as A prime over C prime. Okay, or if you take A divided by B, that would be the same as A prime over prime. This triangle. By the way, did that happen in Robbie's similar triangles? See, we can check that really quickly. So if we think of this side 4 divided by this side, what's 4 divided by 4? 1. Now do the same thing in the divide the corresponding sides in the similar triangle. You have 2 divided by 2, of course, is what? 1. Again, right? Okay. The only one that would be really tough here is if you take the hypotenuse, for instance, right? Here you have square root of 32 divided by 4. That's supposed to be the same as the square root of 8 divided by 2. Okay, are those the same? So, I mean, I know they must be, right? Okay, but let's check it. Square root of 32 divided by 4, is that the same as square root of 8 divided by 2? Well, remember, square root of 32, we learned that was what? That was 4 square root of 2, right? So you have 4 square root of 2 over 4, and square root of 8, remember, was 2 square root of 2 over 2. Look what happens. These numbers divide out and you end up with what? Square root of 2 equals square root of 2. Yeah, okay, so notice those ratios do turn out the same. Okay. All right, so we're going to have lots of opportunities to apply this similar triangle theorem because we're going to run into similar triangles a lot here in the class. Most of the time, our similar triangles are going to be right triangles, okay? Because we're going to be looking at right triangles a lot. Forgot what was on my okay. All right, now just a little bit more for definitions here, and then we'll take a break. So I want to give you a couple of simple definitions, not nearly as important as similar triangles are to us though, but these terms will also sometimes come up, okay? So my question here is, but I'm going to answer the question. The question here is, what is a quadrilateral? What is a parallelogram? Okay, all right, so, triangles are three-sided, enclosed three-sided figures, right? A quadrilateral is an enclosed four-sided figure, okay? An enclosed four-sided figure is called a quadrilateral, so it's got a worse name than triangle, right? The big word quadrilateral. Now, I have to point out to you, and this is important, the sides have to be straight lines, okay? Because you can draw an enclosed four-sided figure that is not a quadrilateral, right? If you draw a four-leaf clover, right? That's an enclosed four-sided figure, but the sides there are not straight lines, right? Okay, so this is not a quadrilateral. But if you have it's got to be closed, okay, an enclosed four-sided figure where the sides are straight line, that's called quadrilateral. So a triangle is an enclosed three-sided figure where the sides are straight lines, right? Okay, well, quadrilateral is just the four-sided version of a triangle. Now, if you have a quadrilateral where the sides are parallel to each other, right? Opposite sides are parallel to each other. Parallel means they're always the same distance apart, right? Okay, so that's called a parallelogram. Okay, so most of the quadrilaterals that you're familiar with from geometry are really examples of parallelograms. Okay, like a square and a rectangle, those are four-sided figures, right? But the opposite sides are parallel to one another. So squares and rectangles are parallelograms. Okay, squares and rectangles are parallelograms. But you can have four-sided figures. You can have quadrilaterals that are not parallelograms. Okay, so you can have irregular quadrilaterals, right? Okay, we just don't work with those as frequently as we do parallelograms. Okay, I want you to, on your paper again, draw for me a quadrilateral that's not a parallelogram. Okay, a quadrilateral that's not a parallelogram, and then draw for me a parallelogram that's not a square or a rectangle. Okay, can y'all do that also at home? So a quadrilateral that's not a parallelogram and a parallelogram that's not a square or a rectangle. Yeah, the quad is the four part, right? Okay, so this one.
That one is Diamond though, diamond is still a square. Okay. I think some other way. Oh, great. All right, so I think
you guys understand the definitions there pretty well. I just wanted to make sure that you got the definitions right. So if you just draw some, it's kind of 4 random sides here, right? You're probably going to end up with a quadrilateral that's not a parallelogram. Actually, this one that I drew is a little bit not kosher, because this one is called not convex. Everyone that you drew was convex, but this one I drew is not convex. Here's what I mean. It's possible in this quadrilateral to start at this point and travel over to this point. If you do that on a straight line, notice that you're going to notice if you do that, you're going to run outside of the quadrilateral. Okay, if that's the case, that's called not convex. All right, and so but y'all, I don't think any of y'all drew a quadrilateral like this. Okay, I think in all the quadrilaterals you drew, if you go from one point in the quadrilateral to another point in the quadrilateral, you'll stay inside the quadrilateral, right? I think so. Well, anyway, and here is an example of a parallelogram. Okay, right? Okay, see, the sides here are appear to be parallel to one another, right? Okay, but that's not a square or a rectangle. All right, actually now we're not quite, by looking at this, we're not looking at this quadrilateral that we think is a parallelogram. We're not quite certain that that is a parallelogram, right? Okay, I just told you that it was, but if we were trying to convince ourselves that this really is a parallelogram, it's certainly a quadrilateral, right? Okay, but if we were trying to convince ourselves that it really is a parallelogram, right, I would have to know this side is parallel to this one, and this side is parallel to this one, right? Well, that looks to be the case, correct? Okay, that looks to be the case, but how can we convince ourselves that that's the case? Okay, well, there's an easy way of doing that, right? And that's stated in this problem. So it says, if you have a quadrilateral, you're going to know it's a parallelogram. You're going to know it's a parallelogram if its 2 diagonals bisect each other. So the 2 diagonals have to cut each other exactly in half. So I drew the 2 diagonals here for this supposed parallelogram. And what I want to see is, do they cut each other? Do these diagonals cut each other exactly in two? Okay. How could we easily figure out that these two diagonals cut each other exactly in two? Get the midpoint, Robbie, of what? Well, it doesn't have hypotenuses because it's the midpoints of what points? Well, you're talking about the midpoints of these 2 points, right? And the midpoints of these 2 points, right? Okay, so that's right. If you calculate the midpoint between S and Q and the midpoint between P and R, if those turn out to be exactly the same, then that means that these two diagonals cut each other in two, right? Okay, so what I'm trying to figure out is the midpoint between S and Q the same as the midpoint between P and R? Okay, if those turn out to have the same midpoints, then know that these diagonals cut each other in two, and therefore we know this really is a parallelogram. Okay. All right, well, let's calculate those midpoints in a second here, but let's stop momentarily, okay, for a few minutes and take a break. We'll come back and calculate the midpoints when we come back. That's easy, right? Okay, so because we've already reminded ourselves of how to do that. So you can probably actually calculate those easily while we're on the break and convince yourself of what the correct answer is here. All right, so guys, I'm resuming the recording, everyone on Zoom. We're starting up again. Just want to remind you on quadrilaterals, right, that I said it, but the figure has to be enclosed. So, you know, if you have a four-sided figure that's not enclosed like this one, then that doesn't count as a quadrilateral, right? You want an enclosed four-sided figure, okay? Like this one, okay? All right, so again, we were just trying to demonstrate that that was a parallelogram, the easy way, by showing that these two diagonals will bisect each other. They'll cut each other exactly in two, right? And we do that by finding the midpoints, right, between these opposite corners, right? The midpoints between S and Q and the midpoints between P and R. If those turn out to be identical, then we know these diagonals bisect each other, right? So what is the midpoint between S and Q? That's so easy to calculate, right? You really don't even have to write it down. All you have to do is just average the coordinates, right? So you can really just do that in your head. So let's see, what would that be? Would add the two x coordinates, right? So we would have 2 and 4 added together. Divided by 2 is what? 3, right? Okay. And then for the y coordinates, right? Take 7 and 4. So that's add those and divide by 2. So that's 11 divided by 2, 11 halves, right? So we can just write that as 11 halves, right? Okay. What about for P and R when we calculate the midpoint of that diagonal? So we have 1 plus 5, right? Divided by 2. Well, that's 3 again, right? And then 9 plus 2, right? Divided by 2 is 11 halves, right? Okay, so pretty clearly, right, this point right here in the middle is 3 and 11 halves, right? And so these diagonals do bisect each other. They cut each other exactly in two. So that means that this quadrilateral has to be parallelogram. Okay, so there's an easy way to test if quadrilateral is a parallelogram just by calculating midpoints of the two diagonals, right, across the quadrilateral, and if they come out the same, then you know quadrilateral is a parallelogram. Now we're going to revisit a problem that we used for our recall practice, okay? And now you'll need some graphing paper for sure. All right. So in the recall practice, right, we just demonstrated what the midpoint was, right, between these 2 points. So that turned out to be right there, which was whatever that was, right? 11 halves and what's that? 11 halves and what?
3 halves.
1 1/2, right? Okay. So this point is 11 halves and 3 halves. Okay, now I've got a tougher question though. So we're gonna solve this two ways, but you're gonna solve it first graphically, okay? And try to give me an estimated answer. We'll see how good your estimate turns out to be. May turn out to be perfect, or maybe it's not that hard to solve graphically. But then we're also gonna solve it analytically. So analytically means just with pencil and paper, all right, without referring to the graph, okay? Although we can certainly look at the graph. That might help us in our analytical solution, but technically the analytical solution we could achieve without applying on the graph, and that solution will be exact. Okay, so our analytical solution perfect. Our graphical solution might just end up being an estimate. All right, now here's what we want to find. I want to find the point on the x-axis. The point has to be on the x-axis, which is equidistant. That means the same distance from these two given points, not the midpoint here, the same distance between from these two given points, okay, 3 and 4 and 8 minus 1. Now, clearly the midpoint is the same distance, right, from these 2 points because it's halfway between the 2 points, correct? So this distance and this distance are the same, but that midpoint is not on the x-axis. I want to find the point that's on the x-axis, and there may be more than one actually. So maybe I should have said points on the x-axis that are the same distance from these 2 points. Okay, so you know if I just pick out, we just experiment here. Say you pick out this point on the x-axis, so that's right there, 2 on the x-axis. Of course, the y-coordinate is 0, right? Okay, because it's on the x-axis, so the y-coordinate is 0. But here the x-coordinate is 2. So that is not the answer. You can see that not the answer to the question, right? Because this distance, correct, is got to be shorter than this distance. I mean, you can just see it, right? Okay, this distance is longer than this distance. So that's not the right answer. I want the answer on the x-axis that is the same distance from these 2 points. So, for instance, clearly this point is not it either, right? That's not the right answer. That's way off, right? Because the distance from this point to this point is very short, right? But this distance to this point is quite lengthy, right? So this is not the, what is that one? 3, 4, 5, 6, 7, 8. That's 8, right? On the x. That's not obviously that's not the right. Okay, so so where is that point on the x-axis that is the same distance from those 2 points? All right, so see if you can on your graph paper. So you guys at home, you'll have to just simulate this set of axes and plot these 2 points, so as best you can. So try to make your drawing as accurate as you can. It's a little bit easier with graph paper though. With your graph paper, go ahead and plot these 2 points and see if you can just do a little experimentation there. All right, you don't have to actually calculate any distances unless you just want to. I want you to just sort of physically position the correct answer here, right? Just physically position the point on the x-axis that you think is, eyeballing it there, the same distance from the 2 points, right? Okay, so when you put the point on the x-axis, now you've got to tell me the once you've made your choice, you've got to tell me what the x-coordinate is though, right? The y-coordinate is 0 because it's on the x-axis, but once you've moved that point to where you think is the right spot on the x-axis, then give me an estimate for what the x-coordinate is so we can know what that exactly what that is, right? So that's your estimated solution. Okay. All right. So I'm just gonna watch out a little bit while y'all try to converge on an answer there. Okay. And then we'll look at some of our answers and see how people agreed or not, or maybe everyone. That's When you get it right, I'm saying, nailed it. It's like, so. Once you put it, you're gonna estimate what that's worth. Then that's the. But check. One more. Go. It's gotta be on the exact, that's just the problem. That's what makes the problem. Oh. There it is. Don't put something down there. Don't make your estimate. Okay. All right. Okay, most people now wrote down something as an estimate for, as their estimate. Okay, for where that number is on the, where that number is on the x-axis. And what did you, Hannah said 3.5, okay? So that's how she saw it. She said she thinks it was right here at, right there. Is that 3.5? No, that's not. Oh, yeah, right there. 3.5. Okay. All right. So that was Hannah's estimate for the solution to this problem. 3.5 and 0, right? It's got to be 0 on the y-axis, right? So Hannah thinks this distance and this distance should be the same. Okay. All right. All right. So, but Hannah, we can check that, right? Okay. So, we're going to try that. Did people get different answers? We get something different from 3.5. Some people put 4. That's pretty close to 3.5, right? Okay. So you're definitely in the right vicinity. Okay. What about at home? Did y'all get something different from 3.5? Someone answer me.
I would say around 4.5.
4. So,
4.5.
oh, so there's a 4.5. Okay, so there's a vote for 4.5. So we've heard 4. We've also heard 4.5. Something else different from that? Who answered me there?
Oh, it's Christopher.
Okay, Christopher. Thanks. All right, so Christopher says 4.5. All right, so let's check those. Okay, so let's actually compute now these distances. All right. So for you guys on Zoom, I want you to try, check Christopher's answer. So Christopher said he thinks the point is not at 3.50. He thinks the point is at 4.5 and 0. Okay, so that's what, when he looked at it, he thought this halfway, this close, this point on the x-axis at the same distance is 4.5 and 0. And then some people in the class suggested, oh no, they think it's 4 and 0. Hannah's original answer is 3.5 and 0. Okay. All right. So we're going to test this and see, okay, if any of these are right. Right. So for you guys at home, I want you to compute, since Christopher said 4.5, I want y'all to calculate the distance from 4.5 and 0, right? That point right there, to these 2 points. Okay, so the distance from 4.50 to 3.4 and the distance from 4.50 to 8 minus 1. Calculate those 2 distances for the people at home, right? Okay, so all of y'all do that. This point, okay, to these 2 points. So you'll have 2 distances for me. You'll need a calculator, right? Okay, to help you with the computations. For these people on this side of the class, I want y'all to try Hannah's answer. So 3.5 and 0, okay? 3.5 and 0, it's these people. And for these people, this calculation on this side of the class, let's try with and see how far that is from. So this is your distance, right? And compute for me those distances, right? So for home, it's 4.5, 0. For this side of the class, it's 4.0. For this side of the class, it's 3.5 and 0 to both. You gotta do it to both of those points, right? Because you know, otherwise you can't tell if those 2 distances are the same. Okay. All right, so. I think that's. So when. Yeah. That perfect. Yeah, you know, but it did write that down. Just. Yeah, what is it? That's what. Good couple. But that's, so that's one of the. You gotta do the other, oh, yeah. Okay. So remember, there's two distances in the calculus, right? Okay. Back up. Okay. Oh. Okay. All right. So most of y'all have made a lot of progress here. All right. So let's go ahead and see what we got. Okay. So for you guys on Zoom, what were those two distances? What were those two distances from this point, 4.50 to the 2 points? There's going to be two of them. So just give me both of them. It doesn't matter the order there. Just give me what those two distances were.
Would you like the true values or the approximate, like square root?
So yeah, keep going there. What?
Yeah, so the square roots I got for I got 13.25 and the square root of 13.25 and the square root of 18.25.
So square root of 13.25 for one of them, and square root of what?
Square root of 18.25.
Well, that sounds kind of large there. 18.25?
Yeah, I can double check the math class now.
Is anybody else at home got something different for the two
I
distances?
got the same thing.
You got the same thing? Mauricio's got the same thing. Anybody got something different from these two? Okay, well, all right. So if we've got some confirmation there, then I'm going to go with that. So these two distances were square root of 13.25 and square root of 18.25. The big thing is they're not the same, right? Okay, so those two distances are not equal, right? And so so this cannot be the answer, right? So whoever suggested that as an answer, I forgot who it was now, right? Okay, good try, but we can see it's not quite the correct answer, right? Okay, of course, this is hard to do by eyeballing, right? Okay, hard to do by eyeballing it, so it's not really a surprise, right? that we didn't get this, our estimate is not exactly correct. What about the 3.5 and 0? So for this half of the class, what were those two distances from this point to the two given points? I think one of them was what, the square root of 16.25, right? And what was the second distance? Square root of 21.25? Oh, okay. All right. I wasn't expecting those numbers. That's why I was surprised when the people at home answered this. Okay, so this surprises me too, but that's it, right? Okay, so we got square root of 16.25 and square root of 21.25, right? So still not the same distance, correct? So 3.5 there is not the, unfortunately, they're not the right answer. Okay. What about for 4 and 0? What did y'all get for those two distances? Square root of 17, and what was the other one? Oh, square root of 17. Yay, those two agreed, right? Okay. So actually 4-0 must have been the best estimate, right? Okay. So at that point, I don't know if I have it plotted here, right? Okay, but it's the point 40 on the x-axis that's equidistant from these 2 points. Both distances are square root of 17. Okay. Well, that's a tough question to answer graphically, right? Okay. Some people got the answer. They got the 4 and 0, but some people got 3.5 and 0, not quite the right answer. And some people got 4.5 and 0, also not quite the right answer, right? Okay. So this one is hard to accurately, confidently answer graphically. So now let's see how we can solve this same problem analytically. All right. So how can we do this with pencil and paper where we don't get a graphical estimate? Okay. So this is now where our geometry and our algebra is really going to help us. Okay. All right. Let's see if we can do this. Let me erase some of this that's in my notes. So I'll have some room to work here. Okay, so we're looking for this point on the x-axis, but that point to us at this point is unknown, right? We don't know its coordinates. So we're going to have to make up just a name for our unknown point. All right, okay? A very typical process in math, right? I'm going to choose a name for my unknown point. All right. Well, it's a point though. Okay, and it's on the x-axis. So what do we know that unknown point looks like? The y has to be 0, right? So sure, right, because it's on the x-axis. So the point's not really completely unknown to us because we know the y coordinate, right? The y coordinate is 0. What we don't know though is the x coordinate. So I'm going to have to give a name for the x coordinate of my unknown point. What do I want to call that? Well, it's an x coordinate, so my first choice would probably be x. Okay, all right. So let's just call that missing x coordinate x. All right. But if you want to call it something else like a or b or whatever you want to call it, that's fine. All right. We're going to pick a variable there to represent that unknown x coordinate. Okay. Now we're going to do a little bit of algebra and geometry with this unknown point. Okay. Right. And we're going to do the same thing with the unknown point that you guys did with your estimate points. I'm going to calculate the distance from that unknown point to my 2 given points. Okay. But I don't know what the x coordinate is, right? So I'm not going to come up with a specific number. I'm just going to come up with an expression. All right. So let's calculate those 2 distances. So I have the distance from my unknown point, right, to one of my given points, which was, what was that first given point there? I forgot. Was that 3 and 4? All right. So let's calculate the distance from my unknown point to 3 and 4 using our distance formula. Sure, right. Okay. So what do? I think you take the difference in the x coordinates, correct? and square that. But see, this x coordinate is a variable, so you're going to end up with x in your distance calculation, right? So it's x minus 3 squared plus, now the other one's a little bit easier because these are both numbers, right? 0 minus 4 squared. And take the square root of that, and that is the distance from your unknown point to the point 3,4. Let's simplify this a little bit. So this is going to be the square root of x minus 3 squared. I'm going to write just plus 16, and I'm not going to simplify it any further at this point. We'll get to that in just a second. I could simplify further by squaring out the x minus 3. And I probably will have to do that eventually, but let's put that off for a second, okay? When I, again, remember, when I use the term simplify, I mean do arithmetic by hand. So you can square x minus 3, right, by hand. So we could further simplify this, but I'm going to delay that for a moment. What about the other distance? So that's the distance to, what was the other point? Can I see that one? 8 minus 1. So, so easy, right? Now that we've seen this one, it's going to be what? X minus 8, right? Squared, is that correct? Plus then, 0 minus a minus 1. Take the difference in the y coordinates. So 0 minus a minus 1 squared, right? And so that is the square root of x minus 8 squared plus, that looks like 0 minus a minus 1 is 0 plus 1 squared. Well, that's 1, right? Now, here's the key thing, right? We want these two distances to be what? Equal. So we're going to just force them to be equal to each other. I'm just going to set them equal to one another. So I have x minus 3 squared plus 16, the square root of that equals the square root, x minus 8 squared plus 1. So see, I noticed that process, right? Very common in algebra and also in calculus. So it's going to be common in here as well, right? I had to use a variable for my unknown, correct? Because I didn't know completely the coordinates of this point. So I picked the variable x to represent the x coordinate. And then I encoded some of the information that I knew here, the distance from this variable point to my two given points. And then I remembered, oh yeah, those two distances have to be the same. So I set those two distances equal to each other. That's very convenient because when I set those two distances equal to each other, I get an equation, and that equation has an unknown in it, but I can solve the equation, right? So, well, hopefully, right? Okay, I can solve the equation for x, right? So when I solve the equation, I'll know what that x is, right? What is that, what that x coordinate is supposed to be. I think now it's going to come out to be 4, okay? But let's see what the algebra tells us. It better come out to be 4, right? Or something is fishy. All right, now, how do you guys go about solving that equation? So what would y'all do first? There's more than one way to do this, but what would be your natural instinct here? It's probably correct. Square both sides. Yeah, that's what I would do, is square both sides, because I want to get rid of the square roots, right? So I'm going to square both sides. Remember, when you perform the same operation to both sides of an equation, usually you can do that and keep the equation balanced. You can do it here. So you can square both sides and eliminate the square roots. Now you still get kind of a messy equation, all right, but at least it doesn't have square roots in it. So that's an advantage already. So we come up with this equation. Any ideas now for step 2? This is looking better.
Do you switch both sides, the equation, to put the x squared, I mean the squares on one side and
Yeah, we're going to do that. We're going to do that, Macintosh. But before we do that, so that definitely is going to be part of solving the equation. That's a common part of solving equations. Before we do that, though, so you want to rearrange terms from right to left in the equation. Before we do that, though, let's simplify both sides of the equation. So simplify again means do the arithmetic that you can by hand. Okay, that's what I mean by simplify. All right. So there is some arithmetic on both sides of this equation we can do by hand. You can square out the x minus 3 and you can square out the x minus 8. Okay. And then once you've done that, you might have some further arithmetic even that you can do by hand. So that's what I want you to do for me now, guys, both at home here and in class. Square x minus 3 for me and square x minus 8. Be very careful when you're squaring x minus 3 and x minus 8, because you're prone to make a mistake there when you do that called freshman's dream. Okay, so we don't want you to make that mistake. So what is x minus 3 squared? And what is x minus 8 squared? All right. Okay, so you guys try that at home. And I'm going to watch off here. And just make sure you're properly. Oh, that's all. Try to make sure y'all don't make any mental mistakes. Okay. Oh, okay. Where? Where's my? Oh. Ah. Well. Where is my going from there? Oh. Maybe you should write. Well, I took. Oh, I see. reason you should. Plus, it makes mistakes. So what I all right, so what I expected to happen happened. Okay, so probably this happened to you guys at home too. So what I expected to happen happened here, and so this is why I had this practice in the question. Okay, in the notes is you guys are having trouble squaring x minus 3, simplifying x minus 3 squared, and then likewise you're going to have trouble with x minus 8 squared. Okay, the mistake that students always want to make is when they're seeing x minus 3 squared, they're thinking, oh, that must be x squared, and then it must be the minus 3 squared, which would be plus 9. So a lot of times they're writing the answer is x squared plus 9, or sometimes they'll write x squared minus 9. That's all completely wrong. Okay, that's the mistake called freshman's dream. All right, so that's a mistake that you want to cure yourself of quickly, okay, because it is a problem that recurs in calculus, and if your calculus teacher sees you do this, they're going to hit the roof. All right, they're just going to flip. So so you don't want to make this mistake outside of pre-calculus, right? So let me show you how to do this properly, but it's easy to do it properly. You just have to remember, when you're squaring something, that means you multiply it by itself. Okay, so here you have to actually physically do that. Take x minus 3 and multiply it by x minus 3. Okay, and slow yourself down and remember, how do you multiply 2 terms times 2 terms? The way you do it is what?
That's first, oughta, inner, last. I did that. But I'm stuck after that.
Okay, all right, Mantosh. Well, we're gonna unstick you, but you're right. First, outer, inner, last. Okay, which is often has the acronym FOIL. Y'all heard FOIL method before. Okay, that's what Macintosh is referring to. What he means is you take every term in the first expression, multiply by every term in the second. So what I'm saying there is you have to take x times x. That is x squared. So we do get an x squared here, okay? But that's just not all of it, all right? X times x. Do not write x times x is 2x. So I'm getting that mistake sometimes too. X plus x is 2x. X times x is x squared, okay? Then you have to multiply x times minus 3. See, it's everything here by everything here. So x times x times minus 3, which is minus 3x. I can get I can stop doing 2 at once here. So minus 3x. Now repeat that with the minus 3. See, that was x times these 2 terms. Now take the minus 3 times these 2 terms. So minus 3 times x is minus 3x again. And then minus 3 times minus 3, there is the plus 9. So you do get the x squared and you do get 9, but you're going to get a middle term as well. which is minus 6x. So you get x squared minus 6x plus 9. That's what x minus 3 squared is. See, it's not just x squared plus 9. Let me see if I can squeeze that in here. So we have x squared minus 9x plus 9. Sorry, plus minus 6x, right? Yeah. X squared minus 6x plus 9. Don't forget about the 16 that was hanging around. It's still there. Okay, plus 16 equals 2. And now you have to square the x minus 8. So x minus 8 squared is going to end up being x minus 8 times x minus 8, which is x squared minus 16x. You'll end up with minus 16x plus 64. I skipped a step there, but it's the same steps that you use here. X times x times minus 8 times x, minus 8 times minus 8. And you end up with x squared minus 16 plus 64. So x squared minus 16x plus 64. And don't forget about the lonely one that was hanging on there at the end. Now, we're not through simplifying both sides because the constants can be added together. So you have x squared minus 6x, what is that, plus 25, equals, if I can squeeze this in, x squared minus 16x, what, plus 65? All right, now, Macintosh, this is, now you're where you wanted to be earlier, because now you can move terms around, you see, okay? Now you're ready to shift terms from one side to the other. How you do that now is sometimes a little bit depends on the nature of the equation. Let's move all of the x terms to one side, and let's keep the constant terms on the other side, okay? But that's not always the way you would rearrange terms, okay? Frequently, you'll move all the terms to one side of the equation and keep 0 on the other side of the equation. Okay, that's often the case, but I'm not going to do that here. So let me move all those terms around. So I have x squared minus 6x, and then I'm going to bring the minus 16x over, so that becomes plus 16x. Right? Okay. Oh, I forgot this. I forgot this x squared comes over, so that becomes minus x squared. And now let's take the constants to the other side. So keep the 65 on the right-hand side, but bring the 25 over, so that becomes minus 25. Remember, when you move terms from one side of the equation to another, the signs change. So what happens here? Good things happen, right? The x squareds cancel. So you don't have any x squareds left. Ooh, that's relief. How many x's are there here? Minus 6x plus 16x is what, 10x? Yeah, the notes here are really going to be terribly messy. Equals to 40. And now you can solve that easily, right? What's x there? 4. Right, yeah, divide by 10. But you can just see it automatically that x there is 4. It can be hard to read these notes when I post them. There they are. X is 4. Woo! There it is. Okay. So we already knew that was the right answer, right? But there it is, analytic. Okay. So there we found it just with pencil and paper, right? We really didn't even need the picture at all. Okay. To find their x is equal to 4. Okay. What now? Yeah, we used the distance formula. So you did need to know the distance formula, right? So that was important. Okay, well, we run ourselves out of time on that problem. That's a good, challenging problem. Kind of a very typical calculus problem, though. All right, that sort of complexity is what you'll be facing there in calculus. Okay, forgot what I was going to say here. Right, well, it wasn't important. So I'm going to see you guys on Wednesday, right? So enroll in the WebAssign, right? Okay, and start working on your first assignment. I may post another assignment. You're probably not ready completely to finish that if I post another assignment yet, but maybe by Wednesday, you will be, okay? And I'll see you again on, Wednesday, trying to stay dry. Ready? Sprinkling a moment ago. Okay, all right, guys, yeah, thanks for at home. Thanks everyone that was participating, Macintosh, and I see Kenneth was helping and everyone else, right, at home. And I'll see you guys also on either here or on Zoom next time, okay? You're gonna turn this off.